Hello, everyone. My name is Masahige Mizuyama, CTO of Panasonic Automotive Systems. So today, I'd like to explain the recent achievement and the further challenges on virtualization technology to accelerate SDV. Okay. So this is a kind of acronym play, but these are today's topics. So let me start my presentation. And the first background. Most of things has already been explained by Murata-san by today's presentation. So I go through this part very quickly. As you already know, the future of automotive is driven almost by software. And in the such SDV world, speed is a very critical factor to be competitive. And of course, the speed of product development, obviously important, but also the speed of product discovery to get to the right product to develop through rapid try, fail, improve cycle, including trial in the real field with the real customer, is also a critical factor. That means automotive industry is getting very close to the IT industry in that sense. And to be competitive in the SDV world, so especially for speed, we need to take software-first approach rather than traditional hardware-first approach in like upper side. This is just a different representation of what Murata-san already told. So also, I will go through very quickly. And the software needs to be evolved across the vehicle generations, even with different SoCs or different car lines. And even if hardware is not available, software needs to be developed. So we should define the virtual hardware, and it makes software independent from underlying hardware details. And then we can say software first as other words, software and virtual hardware first and the physical hardware second. And to realize this approach, but I think VirtIO is one of the key technologies to make it. Those are the advantages of VirtIO. VirtIO makes easy to switch from various hardwares, switch between different hardwares such as SoCs and peripheral devices. Also, it makes easy to switch between the different hypervisors. And even for upper operating systems on VirtIO, it makes easy to switch. And the second point is it makes easy to upgrade the software above the VirtIO. For example, operating system version up, like that. And the third point is it makes it easy to migrate from the software which is developed on the virtual hardware in the cloud to the physical hardware in the vehicle. And with recent activities, VirtIO is getting to cover most devices which is required for CDC, and it is to be extending to the to cover other peripheral devices which is needed in ADAS also. And the VirtIO covers also various configuration, including, of course, hypervisor environment. We call it virtual environment, and the non-hypervisor, non-virtual environment, and also multiple ECU node environment, and that kind of distributed systems. And finally, it can also cover cloud-native, purely virtual hardware environment in the cloud. And we already realized the binary compatibility between the softwares on the virtual hardware in the cloud and the software in the physical hardware in the vehicle. And we support multiple virtual hardware instances in a single server entity to be cost effective also, with the recent progress of this development. And the non-virtual, without hypervisor environment, we support VirtIO. This kind of development is also progressing. The technology is called VirtIO Loopback. And then with recent effort, it progressed to support multiple container environment like this with priority control of the I/O requests. And unified HMI. Unified HMI provides us virtual single screen instead of multiple physical displays. It is also based on the VirtIO technology. It is already open sourced, and it has a cloud-based development tool in the cloud-native environment. And also it supports distributed rendering systems using distributed GPUs in a zonal controller. Those are done with collaboration with some major players like AWS and ARM. Sorry. And recently, unified HMI has major progress that eliminated dependency to particular Windows systems. So by that, we don't follow some kind of updates of various Windows systems. Unified HMI now is independent from these Windows systems. So this update is already open sourced on GitHub, and it will be integrated into Azure UCB in this September, and then it will be demonstrated at the Open Source Summit in Japan, Tokyo, in December. And also, there is already strong support and endorsement for VirtIO from semiconductor industry. I asked those companies one by one to ask to get the permission to put their logo in this page, and they willingly accepted it. So the endorsement is spreading to cover most major SoC vendors now. Sorry. So our vision is getting reality now. Since my first proposal to utilize VirtIO for the decoupling of hardware and software at I believe 2018 AMM at Tokyo. Since then, our technology development and the endorsement is getting very progress. And then now we are making a very steady progress toward the software first with freedom of choice of hardware and the explosive development. Explosive development speed with cloud-native development now. And moreover, real vehicle product is to utilize the VirtIO. Some real vehicle product is very close to the SOP. I mean, it's not just a niche one, but the mainstream vehicle. And for others, platform based on VirtIO is under development. So deployment is also progressing now. So from here, I'd like to touch upon the further challenges around the virtualization, especially VirtIO related things. So I think there's 4 further challenges. One is the decoupling of ADAS and hardware also, not just the cockpit. And the second thing is decoupling from system architecture. Computing systems in general keeps going back and forth between the distributed and centralized. So the current trend seems to be going to centralized, but it might goes to distributed again. That will be controlled by semiconductor performance factors, electric power factors. Many things can affect to such architecture. So we need to decouple our software from such a system architecture. The next one is the decoupling of AI and hardware. Currently, AI model seems to be dependent to the underlying AI processors, but we need to find out to decouple AI and hardware with a similar reason for software and hardware. And the next one is coupling of cloud-native development environment, virtual hardware in the cloud, with peripheral models to make the total vehicle development possible in the cloud. And the next challenge is performance and the compatibility issue. There are, in general, trade-off between the portability and performance, or in other words, standard common interface or vendor acceleration. But we want both. We want to maximize performance while to be compatible with standard. Recent some recent activities are progressing for this. Performance and compatibility issue is it is very serious, especially at the memory traffic intensive devices such as GPU or Ethernet. So for such issue, there are several approaches. I introduce here the two of them. One is the mainly done by Google. It has hardware-dependent acceleration encapsulated in the Mesa 3D framework. So there are some hardware-dependent things, but it is encapsulated in the standard framework, and then VirtIO GPU interface is compliant in such implementation. So we can accelerate the graphic performance by the vendor-dependent acceleration things, but it is encapsulated. And the standard interface is compliant. The second example is called virtual data path acceleration. In that technology, VirtIO front-end is same with the common VirtIO front-end, and the back-end is executed by the virtual function hardware of the hardware virtualization, SRIOV virtualization. So we don't need to switch to the other virtual machine context to execute this virtualized data transfer. So it can realize the compatibility with VirtIO standard interface while keeping the performance to be maximized by the hardware acceleration. So those activities is ongoing external from AGL. Those are external activities. But we can utilize those achievements. I think that's a powerful and beautiful point of open source based standard. It's a great thing. And the next challenges ongoing is the standard reference software platform. Last year here, I presented this presentation. Automotive grade Linux can be a hub of those integration of those open source based technologies. It's a very significant and meaningful in the SDV development. And today, as Dan presented, there are already activity for AGL SDV reference platform called SODEV. It is proposed from Honda-san, and then SDV AG is working on this project with Honda's leadership. So this is my conclusion. There are big progress and outcomes around virtualization for SDV. And there are still significant outstanding challenges to be addressed. So let's work together for the success of SDV by open source activity. And the Panasonic, I'd like to mention the Panasonic Automotive is acting very actively in the community activities. We get gold member, Panasonic Automotive Systems get the gold member of Linux Foundation. And as Dan introduced, Ishii-san became the Japan's evangelist of the Linux Foundation. And the Panasonic Automotive also joined the SOFI governance body and leads APAC regional activities. This is my last slide, and there will be various presentations today and tomorrow regarding SDV expert group and the related open source activity like OSPO. So please enjoy those presentations today and tomorrow. Thank you very much.